Hello, I'm Huili. ZheyuanZhang YichiZhang and I worked on a project. We calculate the oxygen saturation based on deep learning. So first, we use a imaging method called optical coherence tomography to get images of the retina. And we can see here in this image the circular shapes with a long shadow, that's a blood vessel. And from each pixel in the blood vessel, we can get the blood spectrum. And from all this spectrum, we will calculate the oxygen saturation. But when we implement the calculation, the problem is we have to go over every underlying physical principles, and that is tedious, and it's very easy for us to miss some factors that affect the oxygen saturation calculation. That's why we need machine learning to function as a black box, so we don't need to consider every factors. So to do it, we used multi-layer perceptron, and we had 405 spectra with non-oxygen saturation. Each spectrum has 21 values, and these numbers were determined by the experimental limitation. We used gradient descent for our optimization, and we used least squares as our cost function, and we normalized for the gradient descent, and we used the momentum by the value of 0.8. In terms of structure, we have 3 hidden layers. The number of neurons were 40, 20, and 10, and our training set to test set ratio was 0.75 to 0.25. And here is the result. So we have 2,000 iterations, and the cost function value converges, and in the lower picture is our final result. And we can see the blue line here is our measured curve, and the green line is our fitting. The orange line are the theoretical oxygen saturation values. The correlation between our measured results and the theoretical values is 0.9, so it's not too bad. So here is our project. Thank you for listening.